All right, so we're going to work with estimating limit values from tables today. And I've told you that the first thing we always want to try is the substitute. What happens if we substitute on this problem? Well, if I put a 5 in here and here, obviously I get a 0 in the bottom. And on top, don't I get a 0 as well? 5 plus 4. The square root of 9 is 3, isn't it? So don't I get 0 over 0? That has a special name. So this is a new piece of terminology for us today. This is called an indeterminate form. An indeterminate form, which means we cannot evaluate this limit in its current status. And let me show you one of the classic mistakes that will cost you points on the AP exam. It looks like something little. One of the mistakes people make is they put an equal sign here. That is not true. And it will cost you points on the AP exam, on the extended response section, if you put that a limit equals 0 over 0. Frowny face. Don't put equals 0 over 0. Put an arrow to 0 over 0. Use the arrow, not the equal sign. That will keep you from losing a point on the AP exam. All right? Now, we have learned that if we try to substitute and we get something we cannot evaluate, especially the 0 in the bottom, we turn to something else, like we factor or manipulate. And in this case, there's no factoring that I can do. And there's really not, I suppose I could try to multiply the top by the conjugate of the top. That might work. But we're going to look at this one with a table. So the first order of business is to get our graphing calculator ready. And let's put the function into our graphing calculator. And we need to do that carefully. Okay? So here's y equals, I'm clearing my other junk out. All right? So when we look at this function, we need the entire top in parentheses. So I'm going to put a left parentheses, and then I'm going to put the square root of x plus 4. I need to get out of that square root, and then it's minus 3, I believe. Minus 3. Then I need the right parentheses. The whole thing is going to be divided by another quantity, x minus 5. Take your time entering the function correctly when we are doing this. So now we have the function entered correctly. All right. Now the other thing that I've talked about is when we're working with the table, I said to go to your table setup, so second window, and to change your, if you are like this on auto, change it over to ask. And if we do that, it does not matter where we start. All right. Once we get that done, then we can go to the table. If we've got other junk in there, we can take it out. And let's go back to our function now. We are interested in what is happening as this function approaches 5. So I've told you we want to pick some values that are close to 5, but maybe not right at 5. So how about 4.8? 4.8 would be approaching from the left. All right, so we go to our graphing calculator and we put in 4.8. 4.8. And our value is 0.1676. 0.1676. What do you think we should try next? How about 4.9? Right? Let's try 4.9. 4.9. 0.1671. So 4.9 gave us a value of 0.1671. Fix my typo here. Let's try 4.99. Get even closer. 4.99. 0.1667. 0.1667 was 4.99. What's going to happen when I put in 5? What do you think? Error. It's going to be an error. We don't even need to do it because of what we know about this function analytically. But if a limit is going to approach a value, doesn't it need to approach the same value from the left and the right? It does. So we better try 5.1. We better look at it from the right side. So let's try 5.1 and see if we're getting something consistent. 5.1. That looks encouraging. 0.1662. 0.1662. That's good news. Let's try 5.01. 5.01. Hey, 0.1666 repeating. That's everybody's favorite number. 0.1666 repeating. That was 5.01. So I think it is safe to say that from the table we can conclude that the limit as x approaches 5.
Mr. Hartley's advisory, please report to the council.
Sorry for that interruption. The limit as x approaches 5 of this function, I'm just going to put f of x, is 0.166 repeating. Now that is a common fraction, by the way, that you may or may not have remembered. That's 1/6. All right. Now, we were told to use a graphing utility to graph the function to confirm your result. We have not looked at the graph yet, so let's look at the graph to see if this makes sense. We've already got the function in, so let's go to our window, and we're looking right around 5, so why don't we go like just -1 up to about 8. And just look at it there. I'm even going to make the y minimum, y maximum a little smaller, -3. And the reason I'm doing that is because I already know what's going on at the function. We just evaluated it. So 1, 2, 3, 4, 5. How about I just do trace? As we approach 5. What do you think? Have we confirmed it graphically? We have. Of course, right at 5, it's going to be undefined. But as we look from the left and the right, this function is approaching 0.166 repeating. All right? Now, what I want to show you, I want to show you a little trick that, you know, is just kind of nice when you are on the graphing calculator. It's another way to get to some of these function values, and it's this idea of using y1 of a value to quickly check some values. Let me show you how this works. It's kind of cool. So I'm going to clear all this junk out. So here's the trick. We press the vars button. We go over to yvars, select function, and select the very first one, y1. Why? Because that's where we put the function. All right? Put a left parentheses. And weren't we checking values close to 5? We were. So let's do 4.9. Now let me show you something. Don't put the other parentheses on there. I'll show you why. Hit enter. There's our value. Now watch how nice this is. All you have to do is press second enter, and it comes right back up. And you just add another 9 or whatever you want to do. Enter. Second enter. Second enter, 4.999. This is a trick that I just learned the other day, trying to help all of you get better. What if I want to do one of the ones from 5? Well, go back here, delete some of that out, and let's do 5.1. Enter. Do second, enter. Let's do 5.01. So the trick there is to leave the right parentheses off, all right? And that's just another option for you to evaluate a limit using a table. Now what I'd like for you to do is, so let's make a note here. The trick, the TI-84 trick, is to do y1 of your value and leave the second parentheses off. All right, leave the second parentheses off, and then just use second enter to keep trying values. Now, I really don't care if you do it that way or if you do it on the table. I really don't care of the graphing calculator. I'm just showing you another option so you can see which one you like the best. Now, what I'd like to do now, I'm going to pause the video, and I'm going to let you try this one on your own. Use a table to estimate the value of this limit as x approaches -8. I will pause the video. All right, finishing this problem up, I just copied and pasted my values from the graphing calculator in. So those are my values, and I approached -8 from the left and the right. I think it is pretty obvious that as we get really close to -8, both from the left and the right, we are approaching 1.5. So the limit as x approaches -8 is 1.5, and we did that by using a table, and we could confirm that with the graph on the graphing calculator. And we are going to stop there for today. I apologize for all the interruptions, that today was picture day at our